let's point out which is the main challenge, which is the problem. All of we fed up daily decision-making problems, then decision-making models have emerged. Those decision-making models consider a set of experts to evaluate a set of alternatives. And they can use numerical values or linguistic terms. Linguistic terms are more in line with human thinkings. Then we focus on them. Actual decision-making models limit the linguistic term set that experts can use to evaluate the alternatives, which biases the solutions. Then we need a model that allows experts to provide unconstrained evaluation using natural language. Thus, we propose to build a new decision-making model based on aspect-based sentiment analysis method, known as ABSA. This model is going to infer the expert knowledge from natural language reviews. This model can even be applied to social networks because there, users evaluate using natural language reviews, different alternatives. So we are going to focus on e-commerce social networks, where the expert, the users, provide the alternative through natural language reviews. So now we go to our model, our decision-making model. We have 3 steps. Firstly, we have the input. We have a set of experts. In our case, those are the users that evaluate in the e-commerce site platforms. And we have an alternative, the entities that the user evaluates in the e-commerce site. Then we have the set of natural language reviews that those experts provide for those alternatives. Next, the ABSA system is going to extract the expert knowledge from the natural language reviews. Here we have the representation of an example of the ABSA system. The ABSA system is going to infer the expert knowledge from the natural language reviews and is going to get a matrix with the numerical evaluation for each evaluation. After that, our decision-making system is going to collect all the numerical evaluation provided by the expert and infer by our model into a collective matrix. And after that, we rank the alternative. So, let's see those steps in more detail. The first step, the input of the system. We have the set of alternatives that are evaluated by the set of experts. We need to extract the reviews from the e-commerce platforms. So we need to download the reviews. We are going to download the natural language reviews and we are going to collect them into a vector for each user. Furthermore, in some e-commerce social networks, experts can evaluate providing numerical values to some criteria. Then we are going to collect these values into a matrix. So we have a vector with the natural language reviews and a matrix with the numerical evaluations. Our ABSA model is going to work on the natural language reviews, the vector with the reviews. So our ABSA system is going to extract the expert knowledge from these sentences, from these reviews, and is going to collect them into a matrix with the infer numerical evaluation. So, how it works? Here I have an example. Firstly, the ABSA system is going to identify all the terms associated to the criteria. For example, here, the ABSA system identified the term dessert and meat, which are associated to the criteria food. Secondly, the ABSA system is going to identify the polarity, if this review is positive or negative according to the term associated to the criteria. In this case, we have a positive polarity for the term dessert, since maybe the user has said that the dessert was perfect. After that, we transform the polarities into numerical values. So we built the final P matrix with the infer numerical evaluation. Then we have this matrix with the infer numerical evaluation and the other matrix, the NE matrix, with the numerical evaluation provided by the expert. Then we have both evaluation. We aggregate the N, and we get a matrix for each expert. This matrix have the best evaluation of the expert. So, after that, we need to aggregate all the evaluation of all the experts into a collective matrix. And finally, we rank the alternative according to the criteria. So, let's see our example, a real case concerning restaurants. We analyzed a set of restaurants from London, and we analyzed the reviews provided by user in TripAdvisor. We analyzed different criteria, such as food and service. So we need to extract, firstly, the natural language reviews, and secondly, the numerical evaluation for each criteria that TripAdvisor allows us. In this case, TripAdvisor allows user to evaluate the criteria food and service. So users can evaluate those criteria with numerical numbers. And they can provide natural language reviews to evaluate all the rest of criteria. So, our first task is to develop a web crawler to download all the reviews, the natural language, and the numerical values. After that, we develop our ABSA system to extract the numerical evaluation from the natural language reviews. So, as any supervised system, we need a trained data. This training data is sensible. Here, we have 1,000 reviews regarding restaurant. So we train our model there, in this set. After that, we apply our model to our natural language reviews that we have extracted from TripAdvisor. And then we get the polarities for each term. Okay? So we have the polarities which are transformed into numerical numbers. After that, we collect all of them according to criteria, and we have the final matrix collecting all the criteria for each alternative. We aggregate this matrix with the matrix that the user has provided us, and we get the NP matrix. We collect all the NP matrix into the collective matrix, and we rank the alternative according to the criteria. Here, I show you a real example of the case of a study. We have a user that have evaluated a restaurant, and the title is Simple Food, Good Price. The body is had the barbecue chicken wrap, and it was very good, good cookback, staff was friendly and helpful. So, the ABSA system is going to analyze sentence by sentence. Firstly, the ABSA system analyzes the title. Here, the ABSA system identifies the term price, the term food, and each term is associated to a criteria. For example, for the term food, food is associated to the criteria food. So, the ABSA system gets a polarity. In this case, the polarity is neutral, since the user is telling that this food is simple. It is not positive, neither negative. So it is just neutral. After that, the system analyzes the first sentence of the body. Here, the user is talking about the food again, but now the polarity is positive, since the user is telling that it was very good, the barbecue chicken wrap. So the system goes analyzing each sentence and get all the polarities associated to different criteria. In this case, to the criteria food and service, and to our general criteria evaluating the restaurant. So we have all the polarities, and we have to transform them into numerical numbers. Here, we have the numerical numbers for all this evaluation. We collect these numerical numbers for each criteria. So we have of numerical rating for each one. Let's suppose that the expert has also evaluated another restaurant. Let's suppose that those are the evaluation. Then we can collect all of them into this matrix, the NP matrix. As this user has not provided numerical evaluations to the criteria. Okay, we are going to analyze just these numerical numbers status from the natural language evaluation. Okay? So let's suppose that we have another expert, an expert 2. Which evaluation are those? Then we need to aggregate all the evaluation for each expert into a collective matrix. This is a collective matrix, and finally we rank them according to the criteria. So in our case of a study, the best restaurant is the first one. We have presented a demo, and that's all. Thank you so much.
Question?